Hello. Right now we're going to look at the segment addition postulate, which I have written out right here. So it's going to seem kind of redundant when I read it. I'll explain why it is, and then I'm going to read through it first, then we'll continue. If A, this is talking about a point, is between B and C, which are two other points, then the segment length for AB plus the segment length for BC equals the segment length for AC. Remember, quick notation thing. This is just talking about the segment AB. If I get rid of that line segment symbol over top, it's talking about the length of that segment. A little tricky with notation sometimes. Second sentence. If AB length plus BC length equals AC length, then B is between A and C. That's basically saying what we just said here, but in reverse. In math, we're very precise about saying things in one direction and then saying things in the opposite direction. So that's why we have both sentences there. Anywho, picture's worth 1,000 words. This is what we've got here. Here is my line that has A, B, and C. They are all collinear. B is between A and C, as we can see in the picture. The length of AB plus the length of AC gives us this whole length AC. So we're going to use this to either find something we are missing or to add things that we already have together. I'm actually going to start over here. So we kind of have two questions going with this diagram. The first one says find xz. So here's x, here's z, y is between them. Since y is between x and z, we can basically just switch out the letters here, and I'm going to write out that equation. Since x is between y and z, xy, its length, so no segment symbol over top, plus yz, its length, equals xz. Notice how that repeated letter they have in common disappears. Okay, and then kind of thinking back to more of an algebra thing, let's fill in what we know. We know that the length of xy is 23 because that's marked in our picture. Plus, we know the length of yz is 50 because that's marked in our picture. So then we don't know xz, but guess what? That's what they want us to find anyway, so that's okay. Even if you had never thought about a geometry problem like this before, your gut would probably tell you I need to add these two numbers together, and that's exactly what you're going to do. 23 plus 50 is 73, so the length of xz is 73. That's all you've got to do there. Probably seems really simple, and that's good because it's not too crazy. Moving along, if wy, so we have a picture here, we're still using the same picture. If wy equals 30, so that means from w to y is 30, so this length right here. Can we use the segment addition postulate to find wz? Remember, between only deals with collinear points. Are w, y, and z all on the same line? Here's wy, here's z. Those do not all fall on the same line. So since they are not collinear, we cannot use the segment addition postulate. So no, w, y, and z are not collinear. We could say w and y are collinear. We could say y and z are collinear, but all three of them are not collinear on the same line like we see in the segment addition postulate. All right, so kind of forgetting about this part, thinking back to what we did here, smaller part plus smaller part equals entire length. That was pretty easy because I just had to add the two numbers together. Now here, I have a slightly different situation. I have the full length from J to L. I have the partial length from J to K. What I'm trying to find is KL. So KL is K to L. It's this part right here. Can we use the segment addition postulate? Sure we can. We have 3 points that all fall on the same line, 3 points that are collinear. K is in between J and L. So we can start with our equation like we did before. Since K is between J and L, then J to K, this part, plus K to L, this part, equals the whole thing, J to L. Let's fill in what we know. So based off our picture, JK is 37, KL, we don't know, so I'm just going to leave it as KL. And whole starting at J, ending at L is 144. Now, if you only looked at the equation we have right here, and you were thinking back to like algebra or math you've been doing for a long time, didn't have any of this other information, you would say, well, I probably need to get KL by itself, which is exactly what you need to do. So this part right here, once we've used our picture, is like solving an equation that you've done before. So how do I get KL by itself? I need to undo adding 37. So to undo adding 37, I subtract 37 from both sides. From here, it works like a lovely algebra problem. 144 minus 37. You can do this in your head, use a calculator, whatever works for you. It's going to be 107. We have found the length KL, which is what they asked for, so we are done. Hopefully now you feel comfortable using the segment addition postulate to find some missing lengths. I hope you have a wonderful day.